The last topic in this section is really the binomial series. That's going to require a little review of combinations and polynomials, but it's the binomial series that we're shooting for. So let's look at the definition of a combination if you've never learned it before. A combination is a collection without regard to order in which R objects are chosen from N distinct objects and repetition is not allowed. The symbol NCR represents the number of, sorry, that's a typo, I'll fix that, combinations of R objects selected from N objects. So when you think about a combination, I like to think about it as you're being dealt R cards out of N to form a hand, right? If you're thinking about playing card games, right? So it doesn't matter what order they came in, right? That's why without regard to order. So it doesn't matter which one's first and which one's second. What matters is that they're dealt to you in your hand. And then you're looking at R cards in your hand out of N cards in the deck, right? So if you're thinking about it in terms of cards, R is the number in your hand, N is the number in your deck. You can't repeat because once you're dealt the ace of spades, you've got the ace of spades. And that's it. So the important part is that the objects are distinct, repetition is not allowed, and the order is not important. And the formula for the combination is n factorial over r factorial times n minus r factorial. And you'll notice there's actually a few ways to notate this. There's NCR, and then there's a big parentheses with n on top and r on bottom. Those are both valid ways to delineate NCR. Just a little side note, why would NC0 be equal to 1? Well, there's only one way to choose 0 objects, right? You take nothing, of course, right? So there's only one way to choose 0 objects. That's actually why 0 factorial has to be 1 the way that it is. Because if you set that into the formula, then n factorial over 0 factorial times n minus 0 factorial would have to be equal to 1. This would, of course, be n factorial over n factorial, and that means that this has to be 1. That's one of the reasons we define it that way. It's because of this way of thinking about it. So there's only one possible way you can take nothing. You just take nothing. There you go. There's one way to do that. All right, so now let's find 10C8 by hand. By hand, oh, interesting. All right, so that's the N, that's the R. So we're going to say that 10C8 is equal to 10 factorial over 8 factorial times 10 take away 8 factorial. Which, now the 10 and 8 factorial is kind of interesting because, here, let me write it out. It's 10 times 9 times 8 times all the way down to 3 times 2 times 1. And then the 8 factorial is 8 times 7 times 6 down to 3 times 2 times 1. And 10 take away 8 is, of course, 2 factorial. So that's 2 times 1. All right, so then what goes away? Well, the 8, 7, 6, 5, 4, 3, 2, 1 cancels with this 8, 7, 6, 5, 4, 3, 2, 1. So all of that's gone. It leaves you 90 divided by 2, which is 45. Well, obviously, we don't want to do this by hand on the regular basis, but we might have to for whatever reason. Now, if we could use a calculator or a Desmos to do this, that would be wonderful. So let me grab a calculator first. And it's real simple. You go to the math menu, you go over to the probability menu inside that math menu, which is number 3, or excuse me, then you choose number 3, and it's going to ask you, okay, what did you want? I wanted 10, and then we might enter here and say 8, enter. And I get 45, just like I thought it was. Wonderful. Me personally, I think it's a little bit quicker and easier in Desmos, so I'll grab Desmos. If you know the combination command, you can type it, but if you don't, you can pull up the keyboard, tell you want the stats menu, NCR, and you would say 10, 8. Oops, if you have your number keys on. There we go. And there it tells you it's 45. No problem. Which, let's do 64, take 2. So I'll use Desmos to do that. So I'll just do NCR. There we go. So if you just type N capital CR, it knows what you want. And I want 64, comma 2. Oop, not 21, 2. And it tells me that it's 2016. Lovely. Well, that's lovely and easy to do with the calculator. Unfortunately, neither Desmos nor the calculator will allow us to use a negative value. That's because when these are programmed, they're usually programmed with statistics in mind, and statistics doesn't allow for a negative n, but calculus does. So we're going to have to be able to figure this out. Oh, sorry, that was 4. Oh, come back. So with a 4 here, right? So it thinks it's 0. It's not going to be 0. We'll figure it out in a second. So to do this, we're going to actually have to use the formula and think about what factorial means. All right, so this would be equal to negative 11 factorial, that's n factorial because that top number is n, over 4 factorial times n minus r, which is negative 11 minus 4 factorial. You just use the formula because Desmos and the calculators will not do this for you. All right, so that's negative 11 factorial over 4 factorial times negative 15 factorial. All right, now negative 11 factorial is negative 11 times negative 12 times negative 13 times negative 14, right? You keep subtracting 1. Negative 15, negative 16, right, times negative 16, and so on. I'll throw one more in there, negative 17, and then so on, so on, so on, right? You're just multiplying, multiplying, multiplying. And then 4 factorial is 4 times 3 times 2 times 1. So there's 4 factorial. And then negative 15 factorial is negative 15 times negative 16 times negative 17. Oh, that's looking familiar. All right, so the 15s cancel, the 16s cancel, the 17s cancel, right? That whole bit cancels with that whole bit. All right, and then 4 times 3 times 2 is 12. Well, say 4 times 3 is 12. So this will make the 12 go away. Not the negative, but the 12 will go away. And then 2 goes into 14 7 times. So that leaves a set negative 7 here. All right, so I have a negative 11 times a negative 1, right, because the 12 went away, but the negative is still there, times a negative 13 times a negative 7. All right, so it's going to be positive, and I just need to know what 11 times 13 times 7 is. And that Desmos can help me with, right? So 11 times 13 times 7 is 1001. So this is positive 1001. Again, no calculator and no Desmos will help you with that. You have to use the formula for it. And in a standard 52-card deck, this is more how statistics works, how many different possible 5-card poker hands are there? All right, so 52 is your N, and you're going to choose 5-card poker hands would be 5 cards. So at a deck of 52, there's the deck, you're going to take a hand of 5 cards. And of course, order doesn't matter. That's why it's a combination. So this would mean I want 52 factorial over 5 factorial times 52 minus 5 factorial, which I'm not going to bother filling out that formula. That is what Desmos is for. So Desmos, you couldn't do a negative 11 comma 4, right? That didn't work. But you can do 52 comma 5. Which is 2,598,960 poker hands, just in case you were interested. And again, that's a very common use for combinations. The negative use is not common, but it can be done. You can also do it with fractions if you wanted to. Just keep in mind, you have to use the subtracting 1, subtracting 1, subtracting 1, and working your way down.